In Algebra 2 is when you first get introduced to this concept. And in Algebra 2, we start talking about end behavior, right? And we say, okay, let's just see what happens when, x is not just 1 or 2 or 5. What happens when x is a million, a trillion? What happens when x is infinity? Where does this graph look like it's going? And then we say, okay, let's just look at when x is negative infinity. Where does that graph look like it's going vertically, right? We call that end behavior in Algebra 2, but that's when we start getting you used to this idea. Now in calculus, we don't longer call it end behavior because we're, grown-up math students now. We call them limits as x approaches positive or negative infinity. So this is exactly what we used to call end behavior from Algebra 2. Okay? Now, a few things to just get down from the beginning. When we talk about infinity, that symbol infinity does not represent a real number. So you can't get on a spaceship, ride along the x-axis, get off and say, okay, look, I'm standing on infinity. Okay, we can go and land at a place called, like x equals 12 trillion, but we can't go to where x equals infinity because that's not defined. We don't even know where it is. It's just out there, all right? What do we use infinity for? We use it to describe the behavior of a function when the values are further than finite bounds. Okay, so like I said before, this is just the end behavior, all right? Okay, so let's talk about horizontal asymptotes. Sometimes when we look at a graph and we look at, what's happening when x is approaching infinity, we see that the graph is sort of like leveling off horizontally. All right, that means that the graph has a horizontal asymptote. Okay, the horizontal asymptote is a line, and it's a horizontal line, and it's y equals a number, because all horizontal lines have y equals something as their equation. This is why when you have to write an equation for a horizontal or a vertical line, and if it's supposed to be y equals 4, but you wrote x equals 4, it's completely wrong. All right, because horizontal and vertical lines in calculus especially have a huge significance. All right, so if y equals b is a horizontal asymptote of a graph, that means the limit as x approaches infinity of f of x approaches b, and the limit as x approaches negative infinity of f of x approaches b. Okay? All right, so let's just take a real example and see what on earth that means. Take a look at this graph, x over x squared, the square root of x squared plus 1. So now we want to look at what happens as x approaches infinity. So suppose this is you, okay? And you're walking towards infinity, x equals infinity, all right? So you walk for years, right? So you reach x equals infinity, close to there. And you're looking up at the graph. What do you see the graph doing? It's leveling off horizontally, all right, like completely horizontally, and it's not passing a certain point. So that means that here there is a horizontal asymptote. Now your friend is walking this way to negative infinity. He sees the graph as doing the same thing, leveling off at that point. Okay, horizontally. So that means we have horizontal asymptotes. So how do we write that in calculus terms? This is you're walking to infinity. So when they ask you what is the limit as x approaches infinity, right? You would say, so if this is y equals 1, then you would say, oh, it just approaches 1, and then it just flatlines at x approaches as at y equals 1, yeah.
Are there always going to be two horizontal asymptotes?
No, there don't have to be. There could be just one.
Can go up, right?
Yeah, there could be just one horizontal asymptote, or there could be two. So what happens then as if this is negative 1, then the limit as x approaches negative infinity of this is negative 1. Okay? Okay, so the graph has horizontal asymptotes, how would you state the horizontal asymptotes?
X
Yes.
equals 1 and X equals -1.
Y equals, because it passes through Y equals. So Y equals 1, Y equals -1. Okay? You can write it in condensed form like this. That works too. Okay? Yeah.
Do we know it's 1 because of the denominator?
Yeah, I sort of, right now I just told you that it was 1, but yeah, and we're gonna go through like all the different ways. All right. So here it says use graphs and tables to find the limit of f of x as x approaches infinity and negative infinity, and then to identify all horizontal asymptotes. So let's graph. All right. So here we go. Y equals, all right, so let's put this in here. Be mindful of your asymptotes. So it's going to be 2x minus 1 over, everybody know how to do absolute value? Sorry, math, number, and the first one is absolute value. So absolute value of x, and outside we have -3, close the parentheses. All right, and I'm going to do zoom 6. Okay. Take a look at that. All right. So if we wanted to look at x equals 1, 2, 3, 10, this is a perfect view. If I want to look at what's happening as x approaches infinity, I could go to my window and I could change the window x max, let's say, if I want to go to like x equals infinity. I make that like, I don't know, a larger number, like 1,000. Okay, it should really start to show at that point. Okay, so do you see how it's leveling off right there? Now, if I do a little bit of tracing, so I want you guys to be, you know, comfortable using your calculator. Look at the y value. What does it look like it's going to level off to? 2, right? So I can say then, for part A, the limit of f of x as x approaches infinity is 2. Okay? Now, if I wanted to look at negative infinity, I can go to -1,000. And you know what? Let's just make that 0 here. So we just see the left-hand side. And if I graph, oh, look at that. And if I trace, where does it look like it's going? -2, right? So B, the limit as x approaches infinity of f of x is -2. Okay? Negative infinity. So what would you say are the asymptotes then? Right, y equals 2 and y equals -2. Now, what if you wanted to use tables? You can do second table. Okay, and here, so we don't want to know what the value is at, you know, x equals 0 and so on. You can change this so you could ask for values. So if you go to, just a sec. So if you compare these properties with the properties that we sort of glanced at earlier, right? The sum rule, the difference rule, the product rule, these were all for limits as x approaches c. And you'll see that it's pretty much the same for limits as x approaches infinity. Okay? So just like you did in the homework where you had, for example, a problem. You remember like one of the last ones that said limit of f of x is 3. So what's limit of f of x plus 2? You remember? Yeah. All of those. So the same thing will apply here. Okay? So this one, it's back. All right, what's the difference?
It's to infinity.
It's to infinity. So when the limit was at x approaches 0, what was the value? 1. All right, well, what about as x approaches infinity? Does anybody remember what it looked like? Let's see. So if you have sine of x over x, yeah, it's like a what? Like a little, yeah. So zoom 6, it's like a, yeah, you are. you're gonna uh,
Maybe you need to change the date.
let me go into